Hi, in this lesson, we'll use variables in NumPy arrays. As you've experienced now, it's very easy to make calculations with Python. This is one of our first calculations from the plain example. The problem is, there is a lot going on in that print function, and I can't totally remember what each number means. In programming, just like in math, we don't just use numbers in our calculations. We use variables. They will help make our programs more efficient and much easier to read. So let's talk about variables first. A variable is like a box with a name that holds a value to be used throughout a program. Let's take this box here and name it velocity. Now let's store the value of 150 inside of it. We can print the value of the variable by using its name in the print statement. To create the variable in Python, we have what we call an assignment statement. There are two parts to this statement: the name of the variable, velocity, and the value we are assigning to it, 150. Again, when I run this program, the print statement prints the value of the variable, not the name. Since we are storing a whole number, the type of variable is called an integer variable. As a reminder, an integer is any positive or negative whole number that doesn't have a decimal. If it did have a decimal, then we'd call it a float variable. A float number is really just an integer with a decimal point. The last thing we need to talk about is how to name a variable. There are a few simple guidelines to follow here. It must be descriptive, meaning the name must describe what the variable is representing. Variable means nothing, whereas width is telling us what it is storing. It can't start with a number, and most often should start with a lowercase letter. Instead of one length, change it to length_1. All letters should be lowercase. And use underscores to separate words instead of spaces. Okay, now let's take our last example and incorporate our variables. First, let's assign our angle to variable. Then we use that variable to simplify our print function. Already that is much easier to read. Next, let's take 150, which is the plane's velocity, and assign it to a variable, and use the variable in the print function. And finally, let's actually assign the entire calculation in the print function to a variable. In this case, we are calculating the vertical component of the velocity, so we create a variable with that name. I called vel_y for short. I added the round function to round the calculation to the nearest integer. When we do this, we then can remove the calculation from the print function and just print vel_y. As you can see, this program is now broken down into logical steps and is so much easier to understand. We import NumPy, create a variable for angle and velocity, then calculate the y component of the velocity, printing out the result. And let's be clear, while you will see something like Vy equals V sine theta in math class, we're doing the same thing in programming, with velocity y, or vel_y, equals velocity times np.sine angle. We're just using more descriptive names. We can always just use letters in Python as well, but that's usually not as effective. In any case, both sets of variables are representing the values that they store. They're just placeholders. The only difference may be when we actually calculate the result. In math class, we substitute in the values and solve. In programming, values are assigned elsewhere in the program, and the calculation is still done with variables. This makes it easy to change the values of the variables and then have the calculations automatically update. The NumPy library gives us another variable type that is very useful when working with vectors, the array. The NumPy array is a variable that can hold more than one value at a time. For example, instead always having to keep track of two variables for the x and y components of a velocity vector, we can use an array and store them both in the same place. Here we store both components in array variable called vel_xy. When I print the variable, I see both values are printed. To create a NumPy array, we have a similar assignment statement in our code. There is the name of the array and the creation code, which is np.array, and we put the values inside of the parentheses. The values must be in square brackets separated by a comma. When I print the array, you'll see both values listed. Let's integrate this into our last program. First, we calculate each component. Then, we create the array with both components as the values, and print the final component array. Already this is super helpful because if we want to do the same thing for a different vector, all we have to do is change the values for angle and velocity, and everything else automatically calculates and prints. This is power of using variables. I only need to change the values in one place and everything else follows. Representing vectors as arrays with their components will also make future calculations with them significantly easier. As you recall, we have to be careful when we work with vectors because they have directions associated with them. Arrays will help us navigate that process. Let's see what this looks like in our editor. First, we'll import the NumPy library as np, and that shorthand np allows us to use that in our statements. And we're going to set up a couple of variables. Angle is going to equal np.degree to radians, and we'll put a value in the parentheses here for now. And velocity, we're just going to assign that variable the value of 128. We have another variable, velocity x, vel_x, which is going to calculate the velocity for x. And that's going to use our velocity and our angle variables in that calculation. We also have velocity y, vel_y, which is going to calculate the velocity for y. And we'll also use our two previous variables, angle and velocity, in that calculation. Now we're going to set up an array. Velocity xy is going to equal np.array, and we're going to put both variables, velocity x and velocity y, in brackets. And then we can print that last variable, velocity xy, which is essentially going to print out the values after the calculations for velocity x and velocity y. So when we run our program, we get these two values. Now we can also change the values for our variables angle and velocity, rerun the program, and it will recalculate velocity x and velocity y and print those in the console. Let's try this one more time. We'll change out the values for angle and velocity, run the program, and get our new values. Awesome! Now it's your turn to use variables and arrays in your programs.